We've been at this for a year. Juggling, struggling, winning, and losing. But the light is ahead, and it invites us not to go back to where we left off, but to break through, to redefine how we relate, to reinvent the way we work, and reimagine how we communicate. This is our moment to build something new.
Hi everyone, welcome to our session today. I'm really excited to be here with you all virtually at PyCon. And today we're going to be talking about the Slack platform and how to develop on it with our Python developer tools. And my name is Shay. I'm on our developer relations team and use she, her pronouns. And on the team, I work on our open source developer tools and focusing on the documentation and education experiences. And I'm joined here by Alissa, who will introduce herself later, but she's also on the DeWael team as an open source engineer, really focused on the technical side of the tooling. And so today's session is going to be split up into a couple of different parts. First, I'm going to give a brief introduction to Slack apps, and then the Bolt framework and the developer tools we offer, and connect that to the overview of our platform. But most of the time is going to be spent with Alissa doing a hands-on Bolt demo. So let's get into what a Slack app is. So enterprises are using tens to hundreds of different apps on a daily basis. I'm sure you're all quite aware of quite a few of those. And when they are using those, different kinds of information is being triggered, spread, acted upon by different people at different times. And so the goal of the Slack platform is to kind of bring that information into the context of where a team is already working so they can see and act on the information together collaboratively. And there are different ways to actually interact with Slack. The first is a workflow app, which is built using our workflow builder tool. But the two we're going to focus on are custom apps and directory apps. And these both use our full suite of APIs and different platform features to allow you to more deeply integrate into Slack. The difference between these are custom apps are built for a single team or organization, whereas directory apps can be installed by any team or any organization directly from our app directory. And to go into a little bit more detail, workflow apps are composed of a trigger and a set of steps. A trigger can be something like a user clicking on the shortcuts button or a webhook fired from an external service. And after the trigger is fired, a set of steps are going to run. And the steps can include things like a user filling out information in a form, a message being posted into a channel, or something happening in an external service, like information being added to a spreadsheet. And workflow apps are no-code solutions, which allows it really easy to plug into existing or net new workflows. On the other hand, custom apps more deeply integrate tools and systems into Slack with a range of native functionality. For example, you have access to a custom UI system to spread across messages, modals, an app home. And you also have access to different entry points like shortcuts, message context, menus, as well as slash commands. And you can listen and respond to different events happening throughout the workspace that's already happening in Slack, like a user joining a team, a message being posted to a channel. And with custom apps, you really control what features and functionality you want your app to have based on its use case. And there are different ways to actually start building apps. You can either start from scratch or use our developer tools. And our main developer framework is called Bolt, which is a framework that allows you to speed up and simplify development by wrapping our different APIs and platform features behind a simple common interface. And Bolt is available both in Python, but also Java and JavaScript. Regardless of which language you're using, Bolt is going to have built-in defaults that make it easier to start building. For example, Python has built-in support for different frameworks like Flash, Django, Cherry Py, but any Bolt's going to have things like token validation and rate limit handling by default. And we try to make Bolt as easy as possible to deploy to a variety of different hosting platforms. So in the Python, if you go to the GitHub repository, we have examples of AWS, Heroku, Google Cloud, and a couple of others. And while Bolt is an abstracted interface, we also have lower level SDKs if you want a more custom approach. These are also available in Python, JavaScript, and Java, but there are also a lot of community-built ones like Go, Ruby, and PHP. And now that we're introduced to the developer tools, I'm going to briefly go over the platform concepts and features, and then hand it over to Alissa to actually walk you through creating and setting up an app. So the platform is composed of a lot of different APIs and different features that you can subscribe to based on your app's core functionality. And the permission model for Slack apps is built around a concept called scopes. And scopes are tied to specific pieces of features and functionality that your app needs. For example, chat write scope is necessary for listening to messages or sending messages inside of a channel. And the command scope is used for features like shortcuts and slash commands. After you add scopes and your app is ready to be installed, your app will have to go through this OAuth flow. And there's a lot of information about this on the API site, so I'm not going to go too deep into it. But the important part here is after they go through that flow, you're going to get an access token that you use to call different APIs. And that access token carries all of the permissions of your app. And so the APIs you're going to be calling are web API methods. And web API methods allow you to post information into Slack and also query for information that your app needs. So something like posting a message or unfurling a link associated with your app, but also collecting workspace users or channels in a workspace. And Bolt has built-in support for rate limit handling and pagination to make it easier to call and handle these APIs. And when posting a message into Slack or using another surface area, your app is going to use our UI framework called BlockKit. And BlockKit is composed of a set of static and interactive blocks that you can control and customize based on your app. And if you're adding interactive blocks like message buttons, message menus, date pickers, things like that, you'll have to handle this interactivity flow for your app. Here, if you're trying to send a message with a button inside of it, you'll see you can send that message inside of Slack and connect this concept called an action ID. And an action ID is something you define, and it handles that specific interaction for that specific button. So when a user clicks that button, your app is going to receive a event about that button click, the user that invoked it, and the associated action ID with it. And this is kind of what that payload is going to look like. You have the type of action, block actions here. You see the action ID at the bottom, as well as the trigger ID. And the trigger ID is used to show user intent and can be used to open modals later on. In terms of handling interactivity, Bolt has a concept of listeners that make it easier to just plug in that action ID and then run the defined function you create. And so as I said, the trigger ID can be used to open modals. You have a collection of surfaces that your apps have. Messages are probably what you're most familiar with, but modals are used to display deeper, either static information or include interactivity, whether it's a user filling out inputs or just deeper interactivity with traditional BlockKit elements like buttons and select menus. And you also have something called a home tab, which is a homepage for your app, essentially, that is built on a per user basis. So you can expose information from your app for each specific user, and that's going to be the information that's most relevant to them. And when building for these different surface areas, you can use our tool called BlockKit Builder, which allows you to create UI either from scratch or using one of the templates created by our design team. And you can drag and drop blocks, modify it however you want, and then copy this JSON payload on the right-hand side. And that can just be plug and played into your existing Bolt app, so you can just switch out what messages you want to be sending and the interactive features that it includes. So BlockKit surfaces are where you're going to be interacting with users directly, but your app also has access to some entry points that expose your app's functionality. Global shortcuts are available via the UI in Composer or via search anywhere inside of Slack, whereas message shortcuts are available on a per message basis, more used, to attach message content to external services, like information from a message into a task. And an example of this is Slack Developer Tools, which is an app that we've built and is available on the app directory. And it can be used to do things like seeing the message content, the user ID, team ID, what the payload is going to look like for your app, but also the message content itself, if you want to plug that into BlockKit Builder and play around with it and customize it for your own app. So what we've been talking about is sending and querying information to and from Slack, but your app may also want to listen to events already happening throughout a Slack workspace, and that's where the Events API can be used. That can be used to listen to events like someone joining a team, a message being posted to a channel, or a link being shared that is associated with your app. And handling Events API events is pretty similar to the interactivity flow, except that you have to configure the scopes or permissions and the event itself within your app dashboard. Then when a user installs it, Slack will know to start sending that event to your app. And just like the interactivity payload, the Events API payloads are going to have some metadata about the type of event here, the team join event, as well as the user, like the ID or the team ID. And so events are typically sent via HTTP, but we also have socket mode if you are behind a firewall or some other restriction. And socket mode can be set up in the app configuration, and it allows you to receive these same events, but by setting up a WebSocket connection with Slack rather than receiving the events directly via HTTP. And lastly, custom apps can plug into Workflow Builder directly using custom steps from apps. And this is a good way to expose your app's core functionality to users building their own workflows, whether technical or not. So that they have a custom workflow they use for their team, they can tie it directly to your external system. And now that I've given a platform overview, I'm going to hand it over to Alissa to give you a hands-on demo of Bolt in creating your first Slack app.
Thanks, Shay. All right, let's dive into the demo and see how we can use Bolt for Python to create a custom Slack app. The code that I'll be working through today is located at the GitHub repository listed right here. So if you don't already have it, we definitely recommend pulling it down. And without further ado, let's go ahead and get started. So whenever you're starting a brand new Slack app, we recommend starting right here at slack.dev. This is where you can find all the documentation for the developer tools that Slack has to offer. Right at the top, you can see we have the Bolt framework, which is what we recommend all developers use when building out their Slack apps. Let's head over to the Bolt for Python documentation, and here we find ourselves in the Getting Started guide. Now on the left-hand side, we have everything that we need in order to build out a Slack app. The basic concept section holds the foundational elements of Bolt, such as the listeners used to listen and handle messages, events, interacting with the web API, commands, modals, and much, much more. Down below, we have the advanced concept section as well, which features more advanced concepts like handling errors, logging, and even introducing custom middleware. For this workshop, we're going to be sticking with the basics, but once you have your app up and running, we highly recommend returning to the advanced concept section to further build out your app. So now that we know where to find the documentation, let's create a brand new Slack app. And here we find ourselves at api.slack.com/apps within the Create a Slack App modal. We're being prompted for two pieces of information in order to create our app, the app name, as well as the development workspace. For the app name, don't worry too much about this. You can always change this value later. But for the development workspace, you want to make sure that you select one that's not going to require administrator approval in order to install your app into the workspace. For that reason, we recommend that all developers create a dedicated development workspace where they can freely test their apps. If you ever want to distribute your app later on, you can still do that. Once we've created our Slack app, we find ourselves on the basic information page of the app configuration. If we scroll down a bit, this is where we can find our app credentials, such as our client ID, client secret, and signing secret, as well as our app level tokens. When we enable socket mode momentarily, we'll receive an app level token, and this is where you can later find that token. Head over to the socket mode navigation link, and here we find ourselves in the socket mode configuration page. As we learned earlier, enabling socket mode allows us to utilize WebSockets, which also makes it much easier in order to develop our Slack apps locally. Once we enable socket mode, we'll be prompted to name our token. And we'll generate it. Here we're given that socket mode app level token. We'll copy that at this point and put it in our .env, our environment variable file within our demo code. For this demo code, we have just two environment variables, Slack app token and Slack bot token. That socket mode app token will go and correspond with the Slack app token. Now that we've got that done, the second thing that we want to do is install our application into the workspace. So we'll head over to the OAuth and permissions page to do so. OAuth and permissions, this page is where we will install and reinstall our application into the workspace as we continue to develop it. You can see right now, we're not actually able to install it into the workspace. The reason for that is that we need at least one scope to be added to the app before it can be installed. So we'll do that now below in the scope section. Because this is a demo, we already know ahead of time the scopes that we'll need for the code that we'll be writing and reviewing. So we'll go ahead and add those in bulk now. We'll be mentioning our app, so we want the app mentions read permission, as well as channels history to be able to read the messages that occur within a channel that our bot is present in. We'll also want the ability to write messages, have our Slack app respond with messages. And we are going to create a shortcut a little bit later, so we need the command scope. With those scopes in place, if we scroll back up, we can now install our app into the workspace. Once we go ahead to install it, we are going to be prompted with a permissions page that will ask us to verify that the permissions that our application is requesting are ones that we want to allow. In our case, we do. We'll click allow. And you'll notice once we've installed our application into the workspace, we've been given this bot user OAuth access token. We're going to go ahead and copy that. This is the second token that we need in order to run and instantiate our Bolt application, and we will also put this in our environment file. There we go. We have our two environment variables. When we're finished in the app configuration, let's go ahead and look at the actual Bolt code. We're importing a couple things here for this demo, but two most notable items are the app class as well as the socket mode handler class. Below in line 10, we're instantiating our app and we're passing in that Slack bot token. Remember, this is the token that we received when we installed our application into the workspace. If we scroll down a little bit, you can see the code that we have here for creating that WebSocket connection using that socket mode handler class. Passing into it our app as well as that Slack app token. Remember, the Slack app token was what we received when we enabled socket mode. Starting that connection, and our code should be in place. Assuming that the environment variables are all set up, if we head over to our terminal and start our server, we get a nice message that indicates that our Bolt app is running. And you can also see within our client, if installation into the workspace is successful, our app should show up in the left-hand bar of the client itself. So our app is present, our application is running, but it doesn't yet do anything. So let's go ahead and add some functionality. Let's say that we'd like to listen for when a user mentions our app by name and then respond to it. In order to do so, let's head back to the configuration and over to the event subscriptions page. First, we must enable events. And then once we've done that, head down to the subscribe to bot events, where we can add the specific events that we would like Slack to send to our application when they occur. In the case of a user mentioning our app's name, we will add the app mention event. Save our changes, and back in the client. Before doing anything else, if we were to send a message right now that included our app's name, no message would be sent to our application. And the reason for that is that your application must be present in the same location and the same conversation that the event occurred in order to witness it. So let's first add our app to channel. And now if we mention our app by name, we should see an event come through to our application on the right-hand side in the logs of our app. And there we go. You can see the event has come through. Most notably, it is unhandled at this point because we haven't created a listener in our Bolt code to respond to and to acknowledge that event, but this is a great place to start to establish that connection. Let's now go over to the Bolt code and introduce our first listener. So as we heard earlier, Bolt as a framework offers us a variety of listeners in order to handle the events that occur within Slack. In the case of the app mention event, we'll reach for the event listener. And with all listeners that we'll see in Bolt for Python, we utilize the decorator pattern seen here, sending in a single argument that helps us identify which event that we'd like to listen for. In the case of the event listener, that's the event type. Right below, we have the callback function that will get invoked every time that event comes into our app. With the event listener, we have the event payload, which includes information like the user that triggered it, as well as channel information about where the event actually occurred. Next, we have client, which is an instance of web client and is what we'll use anytime that we want to interact with Slack's web API. Behind the scenes, Bolt sends on our token information for our application for us, so it's a little less overhead than what we would need to use otherwise if we weren't using Bolt. And last but not least, of course, we have logger for logging purposes. With regard to the types of events and the relationship with the arguments that are available, this will vary. So if you use a different listener, you might have different arguments available at your disposal. We cover a couple of them here in today's demo, but for full information about which arguments are available in which cases, we recommend that you head over to slack.dev. On line 16, we're using that web client to invoke the chat post message method, sending into it the channel that we want our message posted to, as well as the body of the message by way of the text argument. Let's give this a save and head back over to our terminal to restart our app. And once we've restarted it, if we were to send the exact same message that we sent earlier and got no response to, we should expect our app now to respond with the message that we've set up. And there we go, our app is officially communicating with us. Now that we've got our app mention event set up and we're handling it in our Bolt code, let's add another piece of functionality. Let's say that we'd like to listen for a user mentioning a particular word or phrase and respond to that. As you've probably guessed, this is a new event type, so let's go back to the app configuration and the event subscriptions to enable and listen for that event. Here in our event subscriptions, back into the subscribe to bot events section, we'll add another event to our list. And in the case of listening for messages that have been posted to channels, we will use the message.channels event. Give that a save. One thing to note here is that for the events that we'll cover today, we're only going to cover 3, and that's not even scratching the surface of the total possible events that are available for use. If you're curious about all of the events as well as what they do, I recommend that you go to api.slack.com/events for an exhaustive list of all of the different event types that you can listen for within your application. Now that we've added our new bot event, we'll go back to our Bolt code and introduce the corresponding listener for it. So when it comes to listening for messages within Bolt, we'll reach for the message listener, passing into it the keyword or phrase that we'd like to listen for. In this demo, we're listening for the keyword hello. In our callback, we have a couple of new arguments. Message, similar to the event argument we saw earlier, is payload information about the event itself. So in this case, who sent the message and where the message occurred. Say is a shorthand utility function that is actually the same chat post message behind the scenes. The difference between the two is that say automatically will respond to the same channel that the message came into. So there's no need to specify a different channel here. Down below, we're declaring a new variable called blocks, and within it, we're making use of BlockKit. So as we learned earlier, BlockKit is Slack's UI framework for creating interactive and other elements within various surfaces in Slack. In our case, which is a simple section with a little bit of text and a button accessory we're also including for the user to click on. To note about the accessory payload, we are defining an action ID, and this action ID we'll see comes in handy later when we want to listen for which element the user is interacting with within the client. Finally, on line 42, passing into the say utility function, we're just passing our blocks, as well as a text argument that is just a bit of fallback text in case the surface cannot be accessed, for example, in notifications. Let's give this a save and head back over to our app. We'll give it a restart. And now if we send in the keyword that we're listening for, in our case, hello, we should expect a message along with a button element. There we go. We have a message and our button element. Now, even though there's a button here, when we click it, you can see that something is happening here, but ultimately it fails. And that's to be expected. So remember that action ID that we mentioned earlier associated with the button, we're not yet listening for or handling the click event associated with this button. So let's go back over to our Bolt code and introduce that. So interactivity within Slack is all about action taken by the user. So it suits that we reach for the action listener here within Bolt. Into the action listener, we're sending a single argument, and this argument is the action ID of the element that we've defined. So if you remember when we were defining our button above, for the action ID, we selected the value of first button. That is the argument that we're sending in here. When the user interacts with the button, this is the listener, and this is how we identify which event that this callback function should fire for. In our callback function, we have some new arguments. Action is the payload of the action event that's occurred, and then we have ACK. ACK stands for acknowledge or acknowledgement, and is our way to indicate to Slack that we've received the event and that we're going to handle it from here. It's important that you call ACK immediately after the action has come through, because Slack actually requires that you acknowledge the reception of the event within 3 seconds of receiving it. If you do not do that, what will happen is that same experience that we had just moments earlier, where we saw the little loading symbol and then the warning symbol afterward indicated a failure in the application to handle the event that occurred. Now, you might also wonder why we haven't had to use ACK up until this point. And again, it comes down to Bolt. For the other events, ACK is already handled for us by Bolt, but when it comes to interactive actions, we need to call ACK on our own to indicate that we have received it and that we're going to take action on it. On line 51, all we're doing is sending a message back to that same channel saying that you clicked the button. So we're acknowledging that the user has clicked the button. Let's give this a save and test out our code. Now, if we go ahead and click that same button, we received that acknowledgement that we have in fact clicked the button. While we're on the topic of interactivity, let's add another interactive experience to our application, specifically shortcuts. To do so, head back over to the app configuration under the interactivity and shortcuts page. Here we find the shortcuts section, which is where we can define a new shortcut to add to our application. When you create a shortcut, you have 2 different options for where it should appear, global and on messages. This really depends on the functionality of your shortcut and whether it's message specific or if it should be accessible anywhere within a workspace. For our case, we're going to use global. And here we're prompted for a couple pieces of information. First is the name of the shortcut, a short description to indicate to the user what exactly will happen when they run your shortcut. And we have a callback ID. So this callback ID is going to be used within your Bolt code in order to listen for the shortcut being run. So it's a good idea to make this pretty indicative of what it's associated with. We'll save our changes and head back to the client to ensure that our shortcut made it. We'll give the client a refresh just in case. And down in the shortcuts menu, we scroll down to find our application. Here it is. And you can see the launch a simple modal. That's the title that we gave it just momentarily ago. And if we launch it, as we expected, another unhandled request. So we've created the event itself, but we're not yet handling, and we haven't introduced the listener yet. So let's do that now. So when it comes to handling shortcuts in Bolt, we reach for the shortcut listener. And we'll send to this listener the callback ID that we defined when we created the shortcut within the app configuration. In the callback function, we have ACK as well as shortcut, which is the shortcut event payload, and client as well as logger. We're invoking ACK right away to acknowledge to Slack that we've received this interactive event. And down below in line 61, we're using a new method off of the web API, views open, sending into it the trigger ID and the view. And what this will do is open a modal for the user and display the view that we've provided here. In this case, this is a super simple modal. We're just including a little bit of the text, markdown format so that we can include some emojis there as well. Let's give this a save and restart our application. And now if we head into the shortcuts and rerun that same shortcut that we had earlier, we should expect our modal to pop up. And there we go. So as far as modals goes, as this says, this is super simple. And so this is just scratching the surface. It's modals in terms of functionality. You can stack views, you can update views based on user interaction, submitting forms, and the like. And if you're curious about that functionality, even though we don't cover it here, if you head to slack.dev, we have a dedicated section about modals that you can learn all about the things that you can do to take these modals a little bit further. So in this last example, we use the views open method to publish a view to a modal, but modals aren't the only place that we can publish views to, as we'll see in a second. So what we're going to do is introduce the app home tab. So under our app, you can see that we have available two tabs right now, about and messages. And when we enable a home tab, it will sit right here and is basically a great place for aggregate information or any other information that would be useful for the user that's using your app to see at a moment's notice. So let's go back to the app configuration and set that up. First, we'll want to head to App Home to enable the App Home tab. Down here in Show Tabs, we have our Home tab right here, and we want to enable that. The second thing that we need to do is subscribe to the App Home Opened event under the event subscription. Down under the bot events, we'll add a new bot event, and we'll add App Home Opened. Give that a save. And now if we head back to the client, we can see our App Home tab has appeared. Now, if we click that, our expected unhandled request, because we don't yet have our listener set up to handle that event. Let's go ahead and do that now. So back in our code, when it comes to the App Home event, we're going to use the same event listener that we were first introduced to when we used the app mentioned event. So we're sending in the App Home Opened event type, and within our callback, nothing new here. Instead of the views open, we're using the views publish method off of client, sending in the user ID, which is which user that we would like to send this published view to, whose home tab it needs to show up under, as well as the view that we would like displayed. Again, similar to the modal example, very simple, just a little bit of markdown and some user information that we're grabbing off of the event itself, as well as the requisite emoji. Let's give this a save and head back to our app. You can see that this failed, the event ultimately failed. Once we restart though and head to messages and back to home, we can see that the view was successfully published to our home tab. And as before, you can imagine that if a user is interacting with your application, this is a great place to put more information that they would want to access easily as your application grows more complex, such as like aggregate data. So today you saw how to post messages, open modals, and even publish views to the App Home tab using the Web API. If you're curious about all of the methods that you can work with when developing a Slack app and perhaps want some inspiration as to where to go next with your app, head to api.slack.com/methods for a full list and description of each method that's available for development as you move forward. And with that, we have concluded the demo portion of this workshop. Let's go ahead and review some of the points that we learned today. First, we saw how Bolt utilizes a common listener pattern that makes it easy to listen for and respond to events as they occur. Next, we learned about Slack's APIs, including the Web API and the Events API, and how to use them to query and post information back to Slack. We also learned about BlockKit, and we added some interactivity of our own to engage users across multiple surfaces. In the examples we saw today, on a message, in a modal, and even the home tab. And last but not least, we demonstrated how Bolt can speed up and simplify the app development process by abstracting away the most common aspects of it. As you continue building with Bolt, here are some resources to keep in mind. At the top, we have the GitHub repository that houses the demo code that we covered today. And the Bolt for Python documentation can be located at slack.dev. We also have a ton of Bolt for Python samples located at the Bolt for Python repository within the examples folder. And we welcome you to join the Slack platform community at slackcommunity.com. Finally, we're excited to announce, in our continued commitment to making the Slack platform even easier to build on, we've recently introduced an alternative way to get up and running with custom Slack apps by way of a click of a button. I'm going to leave you with a little video that demonstrates how this is done, but you can also see this in action at api.slack.com/tutorials. And with that, we've come to the end of our workshop. We'll stick around to answer any questions you might have, but you can also reach us on Twitter at Slack API. Thanks for joining us today. We look forward to hearing from you, and we're so excited about what you'll build next.